came back with a goatee, and it was gray. And, well, the rest of it doesn't have gray hair. So we took a double take. Is that really you? And it was. So different changes to different people will also affect the biometric. If you go and enroll in face recognition, for example, and you either lose weight or gain weight, and you haven't updated your template, that will affect the performance. If you go ahead and go on spring break, and you come back nice and tan because you've been somewhere nice and sunny and not here, then that may trip it up as well. If you change your hair or do anything, change your appearance, you could go ahead and affect the performance of a biometric. So visiting it regularly also provides you with an increase in performance. So we create an initial image. We update it each time. In this case, we come to class. I see you guys. I'll be sitting in every so often in this lecture. I'll update my template. I get to know. Some people may drop out, and then I might see them on campus and recognize you from this class. We may recognize other people. We put you and a building together. I might see you in Kenai. If you swing by my lab, then I'll update you so you know where I work. And biometrics works in a very similar way to that. It's called template updating. Bertillon used this idea of using body measurements to identify an individual way back in the late 1800s. And he looked at your face, for example, and plotted the distances between your eyes to your nose, the nose to the top of the lips, lips to the bottom of the lips, and all the way down to your chin. Took ear measurements and so forth, and built up kind of a template or a database for criminals, and wanted to know basically whether that individual had come by again. And we use that today to try and build on an identifying trait. So biometrics is defined as the automated recognition of individuals based upon their behavioral biological characteristics. And that's pretty much the definition that we've come to, although if you read in the literature, every different article pretty much has a different definition, but all beats around this kind of bush here. DNA is not a biometric yet, all right? It is not unique to an individual. You may share the same DNA if you're an identical twin, and it is not automated. You have to have some person go ahead and do something to that sample and collect it. So it is not a biometric in the strictest sense of the word. But what is? Anyone suggest to me what the list of biometrics are? What are some biometrics?
Fingerprints.
Fingerprints is one, yeah. Iris. Retina. Voice. Face. Veins. Yeah, vein recognition, yeah. In fact, hopefully we'll get a vein reader in our lab this semester or next semester. It's pretty cool. Anything else? Hand geometry, yes. Not only the shape of your hand, you can also have two-finger geometry as well. They use that in Disney World for access control. What else?
How do you walk?
Gait, yeah, how I walk. And that is especially for locating people at a distance. When we want to identify an individual, we can tell how they walk. Might not be able to get them, but we might be able to exclude someone that's wearing a backpack, for example, or something that's heavy or awkward when they walk from a distance, and then we can change modalities later on, yeah, gait. Anything else? Huh? Keystroke dynamics, how to type.
Scanning the structure of the blood vessels.
Yes, blood vessel analysis, veins, yep. Odor is another one. Okay, you each have a characteristic smell. All kinds of things. Anything that you have, pretty much we can do some form of recognition on it. And each person really must have this specific biometric trait if you want a universal biometric. And that's something that is important. Many of us may not have, if you work in a manufacturing environment or you're just clumsy one day, you may not have all your fingers on your hand. I don't. Hand geometry doesn't work very well for me. All right? So although I have a hand, I don't have all the fingers for it to work properly. So that's one thing. I need to be distinctive enough from someone else. And here comes the difficulty with identical twins. Although Delane Vision, which just recently got taken over by Identics, took their algorithm for skin recognition to a mall in Minneapolis and said to identical twins, we give you $10,000 if you can fool our system. And they got some takers, but they didn't give any money out. And that looked at skin. Your skin is a lot different. And there's two ways of doing skin. One is skin spectroscopy, where we actually send some light into your skin and it will bounce back. And then there's surface texture analysis as well. So It's got to be distinctive enough from other people, otherwise we're going to get a lot of false alarms. Biometric system can operate in two different modes. First mode is verification, and the second mode is identification. Validates a person's identity by comparing a captured biometric already stored in the system. I'm trying to verify who you are, and typically this is done in a one-to-one format. It can also be done with a PIN, so it's not specifically biometric related. You can have other forms of verification of an individual. Sometimes known in the literature as positive recognition or positive identification. And the simplest example of that is access control. To get into the lab over in Kenai, you need to give me your hand. I will enroll your hand into the database. You'll type an associated PIN with it, and then you type your PIN in, stick your hand in, you get into the lab if you've got enough, if you're in the right time to get in. So for example, we have over 120 students use the lab for an undergrad class. We restrict their access due to office hours, and just we don't have enough machines. There's only 12. And so we give them different time periods where they can come into the lab. Grad students can get into the lab all the time. And so it's one-to-one. Your hands are not that different from everyone else's hands for it to be a total identification system. So we give you a PIN. It goes ahead and pulls that template up, does a match against the two samples, and then goes ahead and gives a return score, either a yes or a no. That yes or a no can also be varied depending on whether it's secure enough or not secure enough, depending on where a system administrator would set it. And we're going to come on to that in a minute when we look at errors. In identification mode, typically, and it depends on the algorithm, but typically systems do a search on everyone in the entire database. And you don't claim any PIN or anything else like that. You will stand in front of the sensor and look at it, if it's a face or an iris, and you let it capture it, and then it runs through the entire list and will return back either one or a candidate list, depending on what mode you have it in. So for example, if you go to an airport and you're in a watch list mode, it will go ahead and look at you. You make no claim to an identity. As you walk through the magnetometer, it'll take a picture of you and will run you against a watch list and will return back scores. And it may show that you look similar to someone that they're looking for and will return the list. And then the person that's checking off will go ahead and make that determination. So it will screen you, so to speak. So that's one way of doing it. So we can get into candidate lists as well. We also look at the question of whose biometric data is this. I've got the person, I have them in the database or not, and I want to make sure whether they're there. And the purpose here is to present a single person from having multiple identities or aliases. In some cases, it's not a problem to have multiple aliases. It may sound, in some cases, if you want to use a system and you want to get in, and biometrics you can have in verification mode, you can have multiple different pins. And that pin is kind of your, like the primary key to the hand. Whereas in this case, your biometric is the primary key. We don't want more than one person gaining access to it. An example would be border control. If I'm going to tie my finger to my identity, I don't want more than me coming in. Another example would be in the UAE, they have an iris recognition system where people that cross into the UAE have to go ahead and give their iris. If they have crossed into the border illegally, they'll take a picture of their iris and send it back home. Typically, they'll turn around and come back with different documents, but the eye hasn't changed. So then they kick them back out again, and this is a recurring thing. In Afghanistan, they're using it to repatriate people back into Afghanistan for food, for the UN refugees. And when you get your food, you then look at an iris camera. We don't have any identity of you. We just have your picture of your iris. And there's your food package. Come back tomorrow. Don't come back the same day. We'll know because your eye would have been in front of the camera before. So that's kind of an identification mode. A biometric system looks like that, and it is the same for every biometric. So once you've kind of mastered this diagram, pretty much everything is simple after that. First of all, we basically make a presentation to the sensor. That is either putting your finger on, putting your hand on it, looking at the camera, doing whatever it is to capture the biometric. We grab the sample, we segment